Hello, my dear young students. As we observe changes around us, we see that there is large variety of chemical reactions taking place. We observed that change in state, change in color, evolution of gas and change in temperature. These may be indicators of chemical reactions. Now, we will learn symbolic representations of chemical reactions under the topic balancing of chemical equations. My dear young students, can you recall burning of magnesium ribbon from your previous classes? That when this magnesium ribbon is burnt in air, it gets converted to magnesium oxide. We also perform this chemical reaction. This magnesium strip has changed into this white ash. Now, as a student of science, how will you write this chemical reaction? Let us try writing it in a statement. So, what will the statement look like? When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. So, here I have reframed the sentence and written like this: magnesium and oxygen combine to make magnesium oxide. Now, let us convert this into word equation. So, how do we do that? So, this is the word equation for reaction of magnesium with oxygen. Now, in this word equation, the substances that undergo change, that is magnesium and oxygen, are the reactants, and the new substance formed, that is magnesium oxide, during the reaction is the product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are always written on the left hand side with a plus sign between the two reactants, and yes, similarly the products are written on the right hand side with a plus sign between them. Here only one product, that is magnesium oxide, was formed. So, I have written only one product over here. And always remember that the arrowhead points towards the products because this shows the direction of the reaction. Now, tell me, can you think of a still shorter way of representing this chemical equation? I am sure some of you have guessed it right. Chemical equations can be made more concise and useful if we use the language of chemistry, that is, chemical formulae instead of words. A chemical equation because it represents the chemical reaction. Now, students recall in class 9th chapter Atoms and Molecules, you learnt about formulae and valency. I am sure you remember. If not, you must revise them. Now, if we recall formulae of magnesium, oxygen and magnesium oxide, this word equation can be written as, for magnesium we can write Mg, oxygen represented by O2 and magnesium oxide represented by MgO. Now, students, along with me, count and compare the number of atoms of each element on the left hand side and on the right hand side of the arrow. Are the number of atoms of each element same? Let us count. Here we have 1 Mg and on the right hand side also 1 Mg. So, these are same, but here we have 2 atoms of oxygen and here we have only 1 atom of oxygen. So, these are not same, and what will such a equation be called? Because it is unbalanced. Mass also is not same on both the sides. So, such an equation is called skeletal chemical equation. This equation, because is not balanced, it is skeletal chemical equation. Now, can you recall law of conservation of mass you learnt in class 9th? What did it say? Yes, I am sure you must have guessed it right. Mass can neither be created nor destroyed in a chemical equation. That is, total mass of elements present in the product side In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Now, in this reaction, let us count the number of atoms of magnesium and oxygen on the left hand side and right hand side. Now, in this chemical equation, in left hand side, there is one atom of magnesium. So, I have represented it in the form of this circle here Mg. Oxygen molecule, which is made up of 2 atoms of oxygen, is represented by 2 circles of oxygen, and here we have magnesium oxide. So, how do we represent this magnesium oxide? Well, this magnesium oxide can be represented by this. And children, do not carry a misconception. In class 9th, in Dalton's atomic theory, you have learnt that atoms are so tiny that they cannot be seen with naked eyes. So, here these are only visual representations to make you understand the concept. Okay. So, let us count and compare the number of atoms on left hand side and right hand side. Well, here we have one magnesium on the left hand side and one magnesium on the right hand side. But in this case of oxygen molecule, we can see 2 atoms of oxygen, and on the right hand side we have 1 atom of oxygen. How do we balance it? We change the number of molecules that we have, and we find a combination that gives us same number of each type of atoms on both the side. So, it is going to be a little bit of puzzle, and we will play around with these kind of visual structures till we get same number of atoms on both the sides. So, are you ready? Okay. So, let me add another molecule of magnesium oxide. Now, young scientists, always remember, to balance the atoms, you cannot add another atom. You have to add a complete molecule like how I have shown here. So, let us again count the number of magnesium and oxygen. The oxygen atom are 2 over here, and on the right hand side 2 oxygen atoms. So, they are balanced now. Oh, but what have we done to the magnesium? Magnesium have become 2 on the right hand side, and here only 1. So, let us balance this also. Here I am putting another atom of magnesium, and yes, now they are balanced. So, this is the visual representation of balancing. Now, we have balanced this equation in the visual format, but how do we write it when you are doing it in your notebook? Well, my dear young friends, you will have to use coefficients. So, here we have 2 atoms of magnesium. So, we need to add 2 as coefficient in front of the magnesium atom, and oxygen molecule is 1. So, it is understood if you do not write anything, that means it is only representing 1 molecule. And here let us count the number of molecules of magnesium oxide, 1 and 2. Okay. So, here also we need to add coefficient 2 in front of MgO. So, now this becomes a completely balanced chemical equation of reaction between magnesium and oxygen. Now, my dear little scientists, let us take another very interesting example of formation of water. Yes. So, here we have a reaction in the statement form. Hydrogen gas and oxygen gas combine to make water. So, what do? First, we have to turn it into a word equation, and for word equation, we have to use a sign of plus between the 2 reactants, hydrogen gas and oxygen gas, and they are combining to form water. So, water is written after the arrow. Okay. So, this word equation can be written in a chemical equation form like this. Now, let us visualize what is happening behind this. So, here we have 2 hydrogen atoms forming a hydrogen molecule. So, I have represented it like this, and oxygen molecule is formed by 2 oxygen atoms. So, here we have the oxygen atoms, 2 oxygen atoms representing this oxygen molecule, which is forming water. So, water is represented like this over here. Now, again let us count and compare the number of atoms of hydrogen and oxygen on the left hand side and right hand side. Okay. So, here we go, hydrogens 1 and 2, and on right hand side 1 and 2. Are you counting with me? Okay. And oxygen on the left hand side 1 and 2, but on right hand side only 1, and we need to now balance this. So, what do? Never add a single oxygen atom, remember. So, we have to add a complete molecule of water. Okay, let us do it. So, here we go. Here we have added another molecule of water. But now what has happened? Okay, by doing so, we have balanced the oxygen atoms. See, you can count and see yourself. But what has happened to the hydrogen atoms? Now, on the right hand side, hydrogen atoms have become 1, 2, 3, 4. But on the left hand side, we have got only 2 atoms of hydrogen. So, what do? I am sure by now you know, and you are trying to tell me that why don't you add another molecule of hydrogen? Okay, so let me do that. And here I have added a molecule of hydrogen, and now every atom seems balanced. Okay. So, this is the visual balancing. How do we write it? Oh, you are so quick. Okay. So, 2 atoms of hydrogen. So, we need to add coefficient 2 in front of this, like this. Oxygen molecule is 1. So, we need not write anything, and here see we have 2 molecules of water, 1 and 2. So, again we will write a coefficient 2 in front of water molecule. So, now this equation is balanced. Now, here I would like to point out a common mistake which students usually end up doing. You know what it is? Okay, let me tell you. What they do is, they feel that we have to balance the number of atoms of each element on left hand side and right hand side. So, okay, the trick they use is H2 and H2 is balanced. So, O2, why don't we make this O as O2? Well children, never do that, because it was a water molecule. Now, by adding this subscript, what have you done? You have changed the entire structure and made a new substance. This is hydrogen peroxide. And while balancing of equations, you cannot form a new substance. So, always remember that you have to always add a coefficient. So, to balance it, we have to add 2. Never children add this subscript. If you add this subscript, the formula itself is going wrong. So, do you get it? Let me repeat that you always have to add the coefficient. You cannot add subscript or superscript, that will change the entire formula, and this equation was of formation of water. So, I am sure you will never do this mistake. Okay. So, now the balancing of water is complete. So, now let us move ahead and quickly do another reaction of formation of ammonia. Now, my dear little scientists, when you have to balance chemical equations, you cannot be always using visuals or drawings. The visuals were used only to help you understand the concept better. But to actually balance equation, see, I have another interesting equation in front of you. Here nitrogen gas and hydrogen gas, they are combining to form ammonia. So, let us quickly convert it first into the word equation by using plus sign between the 2 reactants and a sign of arrow showing that yes, ammonia has been formed. So, in this chemical equation, N2 plus H2 gives NH3, we are not going to use visuals. Actually, to balance equations, you have to use charts or table or little bit of maths, and these chart and table will help us to track the atoms on both the sides. So, let us count the number of atoms of each element on left hand side and right hand side. So, here we have 2 atoms of nitrogen and 2 atoms of hydrogen, and on the right hand side we have 1 atom of nitrogen. So, we write 1 and 3 atoms of hydrogen. So, we write 3. Well, but as you can clearly see that nitrogen on both the sides are not balanced, neither is hydrogen. So, to balance nitrogen, what can we do? Let us multiply this with 2. So, we get 2 atoms of nitrogen on the right hand side, and to balance the hydrogen, we will have to multiply the hydrogen this side by 2 and make it 6 atoms of hydrogen. So, here also let us make these hydrogen atoms 6. So, we have multiplied here by 3. Now, once you do the calculations like this, you can very easily add the coefficients. Here I have shown the coefficients to be added by red color, so that you can identify easily. So, okay, here we go. We write a coefficient 2 in front of NH3, and in front of nitrogen no coefficient to be written, and in front of hydrogen molecule you have to add coefficient 3. You have got a balanced chemical equation of reaction of nitrogen gas with hydrogen gas forming ammonia. Okay, so we can move ahead now and take up another equation which we will need to balance. So, we are going to take an equation where iron reacts with water to form rust. Do you remember this equation? You have already done this in class 8th, but yes, we need to learn to balance it. So, here is the equation where iron is reacting with water to form iron oxide and hydrogen gas. Okay, so what do we need to do? First, we need to count the number of atoms on both the sides. As we can see, Fe has only 1 atom, and this water, in this water we have 2 atoms of hydrogen. So, we write 2 over here, 1 atom of oxygen. So, we write 1 over here, and here on the right hand side in iron oxide we have 3 atoms of iron. So, I have written 3 here, and hydrogen we have 2 atoms. So, let us write 2, and oxygen we have 4 atoms. So, let us write 4. I am sure you are also tabulating and writing it along with me. Yes. So, now you can see that iron on both the sides are not balanced, hydrogen is balanced, but oxygen again is not balanced. So, what do we do? It is often convenient to start balancing with the compound that contains maximum number of atoms. It may be a product or a reactant, and in that compound select the element which has maximum number of atoms. Using this criteria, in this reaction iron oxide we can select, and which element do we select? Oxygen. So, here there are 4 atoms of oxygen and only 1 oxygen here in the left hand side. So, let us start by balancing oxygen atoms. Okay. So, here there is 1 atom of oxygen. So, what do? We will multiply it by 4 like this to balance it with 4 atoms present on the product side. So, now oxygen is balanced, but what have we done? If we have multiplied it by 4, that means we need to add 4 coefficient in front of water molecule like this, but while doing so the number of hydrogens have become now 8. So, here we go, this coefficient we have added here. So, hydrogens have become 8 on the left hand side. So, we need to balance the hydrogen on the right hand side also. Okay. So, let us multiply this also with 4 and add a coefficient 4 here in front of this hydrogen. So, here we write a coefficient 4. So, this is partially balanced equation. We still need to balance iron on both the sides, which is quite simple. Let us multiply iron with 3. Here we go. So, now you can see that all the atoms of each element on both the sides are balanced. We only need to add coefficient 3 in front of iron. So, let us do that. Okay. So, I have written coefficient 3. Have you all noted, children? Okay, that is good. So, this has become our balanced chemical equation. Now, you have learnt how to balance a chemical equation. But students, can you tell me by looking at this equation that what is the physical state of iron, water, iron oxide or hydrogen? It is going to be a difficult task. So, there is one more step we need to learn, that is to mention physical states in brackets just after the elements which are written in the equation. So, here is the balanced chemical equation we have just done. Okay. So, writing of physical states in the form of symbol will make it more informative. How do we do that? Well, for solid state, we will add in bracket a small letter s. For liquid state, we will add a small letter L, and for gaseous, we will add a small g, or we can also show it by a upward arrow. And well, what if the solution is made in water? We have to write within bracket in small letters AQ representing aqueous state. And yes, one more thing, if you get a precipitate, then you can show it by an arrow pointing downwards. So, that will make your equation very informative. So, let us try making this equation more informative by writing symbols of physical states. So, iron over here is a solid. So, what do? We can write S within brackets over here, and this is water. Until unless you mention the physical state, some of the children may wonder that water is in liquid form, but here this is in gaseous form, because iron will not react with cold water, it reacts with steam. I am sure you remember. And this is iron oxide, again it is in solid form. So, we can write S within the brackets, and here is hydrogen gas. Yes, so gas, you can either make an upward arrow or simply write within brackets a small g letter. So, this is now a completely balanced chemical equation of reaction of iron with steam to form iron oxide and hydrogen gas. Well, now sometimes we have reactions where certain other conditions are required. For example, the reaction condition of how much the temperature is, what is the pressure under which the reaction undergoes, or what is the catalyst used. So, various reaction conditions also can be used to make the reaction more informative. Now, if we have a reaction in which carbon monoxide, which is in gaseous form, reacts with hydrogen gas to form methanol, which is in liquid state. So, this reaction happens at a particular pressure, and that is 340 atmospheric pressure. So, such reaction conditions can be written above or below the arrow. Okay. So, now that you have learnt how to completely write a balanced chemical equation, here is a task for you. You have seen green plants all around you, and you know that leaves are the kitchen of the plant. They make their food there with the help of sunlight, chlorophyll, carbon dioxide and water. Can you write this reaction? Try doing it. Here I have got it for you, because I need to tell you that where exactly you will place the reaction conditions. So, here we have the equation in front of you. 6 CO2 combines with 12 H2O to form glucose, that is C6H12O6, 6 oxygen molecules and 6 water molecules. And the reaction conditions? Yes, the sunlight and chlorophyll. This you can place above and below the arrow. Okay. Now, another interesting task for you. What you have to do is, I am going to show you an interesting reaction. Here I have made 2 solutions in water. In this we have lead nitrate solution and in this we have potassium iodide solution. Observe carefully when I mix them what is the new substance formed, because you will walk with me on the path of discovery. Here we go. Wow, bingo, what a bright cadmium yellow. Now, you have to be a discoverer, explore and find out that the reactants, that is the lead nitrate and potassium iodide, if these 2 reactants have interacted with each other, what could be the substance formed? Write it in a form of a sentence and then convert it into word equation. And I am sure you will very easily be able to balance the chemical equation. All you have to do is count and compare the number of atoms of each element on both the sides, and by adding coefficient, you can balance the number of molecules. So, what we have learnt? Yes, how to balance a chemical equation and make it more informative by adding physical states in brackets after you write the formula of the element or compound which is coming in the chemical equation. And yes, always remember that you have to also mention the reaction conditions above and below the arrow. So, that will make your chemical equation completely balanced. I am sure you all young discoverers must be very excited after seeing this reaction. The more you practice, the more you will become perfect at balancing chemical equation perfectly. So, happy learning, dear discoverers.